Hello everyone, thank you for coming out. I am Daniel Hienzsch. I am the resident engineer at the Supplyframe Design Lab. Anybody here familiar with Supplyframe, by any chance? Yeah, fair amount, that's good. Supplyframe is primarily a software as a service company and makes software tools and websites to provide supply chain management tools for electrical engineers, distributors, contract manufacturers, and procurement specialists within organizations. So you can imagine if you've got some product that's got thousands of different line items worth of electronics components in it, making sure that all of those components show up at the factory at the right time, at the right price, and in the right quantity when you expect it can be very challenging. So we have tools that help to manage that process. And then we have some business insight into that component and supply chain management, or into the supply chain. And then we also have some community products, which are really focused on bringing marketplaces out for the ideas of citizen scientists and physical marketplaces, places where you can actually sell things as an independent engineer. So if you might be familiar with Hackaday or Hackaday.io, those are both Supplyframe products. I'm wearing the Hackaday Jolly Rancher right now. And Tindy is a marketplace. You can think of it like Etsy for electronics projects, where when you're done making your 3 prototypes, but you only needed 1, you've got 2 left over, you just put it on Tindy and you can actually find a marketplace of people that are interested in your electronics projects for sale. What I do is I actually run the DesignLab, which is a rapid prototyping facility just on the other side of Central Park here in Pasadena. And it's the physical representation of all of the virtual stuff that Supplyframe does. So we have an event space where we can bring the community together, where we can talk about pretty much anything. We bring engineers, artists, designers in to give talks, we hold workshops. But the primary 8 to 5, Monday through Friday, is what I'm going to talk about today, which is rapid prototyping, about bringing in teams of engineers to help them go from having some concept to the physical reality, the thing that you can hold in your hand that is the representation of this thing that you've only been thinking about. A little bit about my background. I lucked into this job purely. This is, without a doubt, 100% my dream job. You cannot possibly describe a better job for Dan other than the one that I have right now. I have a background primarily in IT, but going back, way back, I went to airframe and power plant mechanics school. So everything from carbon fiber layups to how to take apart a Lycoming engine to bucking rivets in sheet metal and running milling machines. I got a lot of training in that and never thought it would actually come into bear, but sure enough now, well, short of like actually taking apart a Lycoming engine, I use all of these tools on a daily basis in this magnificent facility that is full of just the most incredible modern equipment that you could possibly imagine to, like I said, take that concept and turn it into a physical reality. So the question that I would have for the people in the audience here is, how many of you have been involved in the creation of a physical product, not a software product or financial services, but so like physical product? That's actually a fairly decent amount. For those of you that have not been involved in the creation of a product, my suspicion is that this is what you think that the product design process looks like. Is that the iPhone leapt fully formed from the mind of Steve Jobs, and you shall never know that there were any number of prototypes that occurred before that happened, or any number of tests, or materials tests, or product tests, or packaging tests, like that unboxing experience that you get where you have this almost vacuum seal on the box as you're trying to get to your new phone inside is not by accident. And that didn't just happen. It was a lot of prototyping and a lot of testing that went into every last little aspect of that. But they don't want you to know that. They just want you to think that this thing suddenly appeared. Now there are some exceptions to this, and that usually runs around in the marketing area. You can think of in the automotive industry, when they have advertisements about crash tests. It's not just, oh, we did this once. No, we ran that car into that wall again and again and again and again, and we really tested and we prototyped. But they're trying to just show you that one little aspect of it. Or from the design standpoint, that they used to have these ads when Chris Bangle was still the head designer at BMW, where it would be sort of that that really saturated black background, and there's this lump of primordial clay as you sort of, forming that new BMW 3 Series out of the clay. Like, yes, we're doing all this prototyping and design work, but they're only letting you think of that one particular aspect of it, rather than, for example, a friend of mine that lives in Frankfurt in Germany, and he works for a company called Continental, and his job is to design the LED systems that sit behind the turn signal in various different cars. I mean, this is the most mundane aspect of an actual car, but it goes through revision and prototype and testing and revision and prototype and testing, just like all the rest of the car does. Now, for those of you that have been involved in the manufacturing of a product, this is probably what you're more familiar with, which is this sort of semi-linear experience where you start off with a concept, you eventually possibly kind of get to profit, and there are lots of twists and turns along the way. A couple weeks ago, I was up in San Francisco for sort of a sister event that we hold up in at our Supplyframe office in San Francisco, and pretty much the guy that was presenting was talking about how they went from this concept they had for this FPGA project, or this FPGA product, all the way to actually delivering this, and about the only thing that's on here that they didn't talk about was considering lying about radio frequency certification. They actually chose to actually go and do that, and not just, oh, we're just going to put the little little sticker on the product and say, yeah, we went to the FCC. What I try to do at the lab is find some way of sort of eliminating that first slide and cleaning this part up. Now, there's a reason why everybody winds up going through this, and I think it's because I can read all the books that were written at GM or at Toyota about manufacturing and about the Kanbai process or whatever that is, about how to make these things very, very, very efficient. But man, there's something valuable to the process of at least figuring little parts of it out for yourself. It reinforces this for yourself so that you can personally get better over time. And honestly, now that I think about it, it comes into sort of the philosophies that I have around product prototyping. Now, I'm not going to wind up talking too much about the actual physical process of rapid prototyping, because in order to do that, I need to take all of you over to the lab, and we'd have to sit down and show you, the difference between an FDM printer and an SLA printer, and why our CNC router is different from our milling machine and things like that. What I want to talk about quickly here is the mindset, because I think that's something that everybody can take from this process and apply in practical ways, regardless of whether or not you're building a product or not. So one of the first things I want to talk about here is the acceptance of failure. About, I guess, 4 years ago now, I got laid off from Kane Anderson in Century City. It was a very kind thing, and I tried very hard not to smile and laugh as I shook my boss's hand as he kicked me out the door. I was very happy to be leaving that job, and if Bob Kane's listening right now, I really like working for you. But what I decided, for whatever goofy reason, was that I was going to start my own electronics company. And I can't tell you what my motivation was for that, because I don't know. It just sort of, this idea popped into my head that I now have time and opportunity. And I've been playing around with electronics for the last 20, 30 years. It might be fun to see if I can actually do something that I enjoy and try and make some money at it. And the only reason I chose to pursue that is because the first thought that I had with that was, it's okay if it doesn't work out. So first thought I had was, I'm going to try to think of a product. I'm going to try to think of something that somebody might actually want to buy. But if I don't come up with one, it's okay. I'll just go back to IT. I'll just get another job again. And as I went through, and I literally thought every single one of these questions up here, it turned out that I didn't fail. At every step, I gave myself the permission to fail, but it turned out that I didn't fail, and that allowed me to go forward. Now, towards the end, you start to make mistakes, but I'm going to try to send this board out for fabrication. If it comes back broken, that's okay. So the board came back, and oh my God, did I make some really boneheaded errors on there. And then I thought, well, okay, now I got to figure it out. But who am I? I'm Dan. I'm just some guy that ran IT for investment banks. What business do I have trying to troubleshoot semi-complex electronics thing. But if I don't figure it out, it's okay. But who knows, maybe I actually can figure it out. And sure enough, I did. So you need to be able to embrace failure. And that is the first step. Before you do anything else, you need to look at this concept. You need to look at this thing that you want to build that's been burning inside your head as this thing that you think would be really valuable to a customer base, or to the world in general, or just to you, or to your family, or to your friends, or whatever, and tell yourself it's okay if it doesn't work out. But because it doesn't work out doesn't mean that it wasn't worth trying in the first place. Sort of hand in hand for that is that your idea, your product concept does you no good if it's locked inside your head. You need to get it out of there. And this is really the first thing that I work with the people that come to the lab that are really in that concept stage where they haven't actually built anything yet, is that you cannot think from point A to point Z inside your head and come up with that finished product. You've got to get that rough, dirty, nasty thing, just write it down, make a block diagram, do a napkin sketch, build it out of cardboard. I don't care what it is really that you wind up with at the end of this first initial process. It is the act of doing that that is crucial, because you're taking it out of your head and you're creating some kind of physical reality of it. And that is a very powerful psychological thing for an engineer or for a designer or for an artist. This idea that I have now created this, I hold it in my hand, and now I can show it to other people. And now I can get feedback on that. And now I can get help on that project. I imagine there's some fairly technical people in here who's heard of the phrase RTFM before, right? For those of you that don't know what that means, it means read the manual. Read the fantastic manual.
He said fine, it's less typing.
Exactly. So this is a project problem that you wind up realizing as you start building prototypes, is that there is no manual for you to read. You are in fact writing the manual that somebody else is going to use after the fact. And what the first time this occurred to me was actually not trying to build some sort of complex electronics project, but I was actually building a small piece of furniture for the lab. I basically made my own piece of IKEA furniture to hold a bunch of spools of 3D printer filament. And I got all the pieces out and I sanded them down and I waxed them up and everything was looking good. And then I realized I had no idea how I was going to assemble this. Was I going to use glue? Was I going to use nails? Was I going to use screws? And my first instinct was literally to go look for the little IKEA man and have him tell me how to put this together. And then it struck me, there is no instruction manual for any of this stuff. You're going to have to figure that out yourself. And again, that's okay. And if you do it wrong, that's fine. Just do it well. Just do it quick and move on and try again if it doesn't work out. Did I just make the microphone pop? Okay. And then finally, there is a tension to prototyping. These are the two rules that we've sort of developed over the last few years at the DesignLab. First rule of DesignLab is don't hose it. Yeah, exactly. Don't screw it up. But the second rule of DesignLab is always order 2 of everything, because rule number 1 probably isn't going to be adhered to very well. You try your absolute best to make sure that what you're working on is correct. And I think of this, actually, I see a couple of my residents in the audience right now, and I think of when they are putting their prototypes together right now. They've got some circuit board with accelerometers soldered down onto it, but they haven't really used these products before. And they get them all plugged in and lined up, and man, I really, really hope that they've got them all hooked up correctly, but when you apply power to it, you might release the magic smoke. And if you do, it's a good thing that you bought 2 of them, right? But, first, please try to make sure that you do it correctly in the first place. But don't let that hold you back from trying to do something bold. So with that in mind, the question then is, what actually is rapid prototyping? Because I looked on Wikipedia to try to see if there was some kind of definition for it, and they immediately go into that sort of physical representation of, it's very CAD focused, and you use 3D printers as though this is sort of the be-all and end-all of trying to make things fast. I think it's more a mindset of, I'm going to try to make this, and I'm going to try to make it as fast as possible. More importantly than that, I think it has more to do with the idea of the minimum viable product and sort of the that user experience testing that you get in the software world that really hasn't existed in the physical product world too much. So this is the definitions that I came up with. So first off, it's a method where you can get the product into the hands of your customer as fast as you possibly can, so that you can get feedback from them that you can incorporate into an iterative design for your physical product. For those of you that come from a software background, this sounds very simple. This sounds completely reasonable. What you do is you build your website, you get it in front of your customer, and then you iterate on that design in the background based on the feedback that you get from those customers. Obviously, it's much easier to iterate on the design of a web page than it is on a physical plastic enclosure. So what we do at the lab is try to find ways of getting you to that physical plastic enclosure faster. That doesn't mean that it doesn't go through the same design process, and it doesn't mean that it doesn't take some time to get that design right in the first place. But once you've got that design, we try to remove all the obstacles out of the way of going from concept to physical reality as fast as possible. The other thing, you are going to wind up having to do CAD modeling. I've got a slide of sort of prerequisites for people that would succeed in this environment. But CAD modeling, using automated equipment, 3D printing, CNC machining, rapid turnaround electronics fabrication, these are all things that you wind up getting very familiar with through the rapid prototyping process, because you need to be able to move from one piece of equipment to the next, to the next, to the next, or at least find somebody that can help you move from one piece of equipment to the next, as fast as possible, so that your output from this equipment, your prototypes, are coming off basically as fast as you can think of them. It really relies heavily on collaboration. You have to be working with other people. Although we have had some solo engineers at the lab, I really see like teams of 2 to 4 really succeed the best in this environment, because you have to have people that you can bounce ideas off of. Again, it's getting that idea out of the cage and into the world so that you can bounce it off the wall, you can take it out for a spin and see what it does. I don't think having too much in the way of specialized training is very helpful. I think generalization, having a broad understanding of many processes, is probably more helpful. And if you have a lot of generalists in that team, you have a better overview of what the big picture is that you're trying to work on. If you're trying to build an electronics project, or if you're trying to build an art installation, knowing how you get from point A to point B can be limited if you are an expert in hammers. Again, if all you have is a hammer, everything looks like a nail. So having that broader experience to draw from can be helpful, but that doesn't mean that you exclude the specialists. You bolt the specialists on. Once you get to that point of saying, through our broad knowledge, we don't really have the expertise in order to take care of this particular problem or come up with this solution, so let's go find a consultant. Let's go find somebody that has that specialty that can then help to deliver that solution to us. Honestly, that winds up usually being in the realm of, for us, electrical engineering. A lot of people come in with really solid software experience and to a certain extent some good CAD experience, but the electrical engineering side seems to be the place where they start to not be quite as familiar, and certainly not on the CAM or the CNC front. So this is the sort of method that I have developed for how I work with the residents that come into the lab, and I'll talk about what it means to be a resident in a couple slides. First thing is you set a goal and you set a time frame. Everybody comes in and we figure out exactly when your residency is going to end, because everybody works better against a deadline. And second, we try to find out what that goal is that you're working towards. That goal should be absolutely achievable, but it should also be challenging. Like, it shouldn't be like step 1 on your path. That's not a goal. It should be step 8 or 9 or 10 along the path. But that goal is different for everybody, depending on whether you're coming in with a concept, or you're coming in with a prototype, or you're coming in with a production prototype that you just need to incorporate design for manufacturing for. Everybody comes in at a different spot, so consequently everybody has a different goal that they're working towards. First thing, write a block diagram, napkin sketch that, get it out of the cage moment. Don't just come in and then sit there and stare at Pinterest all day trying to figure out exactly how this design is going to work. You've got to make a physical reality of whatever it is that you're working on. We have a couple of different ways of approaching that, and I think I actually get down to that in a couple of bullet points. You need to look at all the tools that are around you in the lab, and one, don't be intimidated by them. And two, try to figure out the best way of using them, even if the way that you're using them isn't necessarily the way that most people would expect to use them. I think one of the most brilliant things that we've done at the lab is to use the Formlab. So we've got these SLA printers that make these incredibly highly detailed, they're kind of slow to print, but very, 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 very finely detailed 3D printed models. It's incredible fidelity to your CAD. And we didn't use them to print the model, we used them to print a mold into which we could cast polyurethane. That little step beyond what you usually use the equipment for really unlocks an incredible amount of potential in how you can actually get to a solution faster. There are different ways of working, and I'm not here to tell you the best way for you to work. Everybody works differently. Again, I'm going to keep picking on the Lighthouse guys because they're sitting right here in front. The Lighthouse guys came in, and you guys right now are designing circuit boards, you're soldering down your accelerometers, and yesterday you were dropping 10-pound weights on the floor to see if you could detect the vibration through the earth. This is a very engineering, I would say, approach to prototyping. They have an enclosure that they've already thought about. We printed it on the first day, haven't seen it since. You guys have been working on the electronic side, doing the hard math for your product, and that is exactly the best way for them to proceed. On the other side of the lab, we have a group called the Cherishables group that are working, again, on an electronics project, but what they've been doing is working on these scale models for what their enclosure is going to look like. They're working on the electronic stuff sort of on the side as well, but really they're trying to get an understanding for the form and the feel, and they print out, I think they're on their 15th or 20th iteration of this design, looking for exactly the right way that it's going to feel in your hand when you start to actuate it, when you start to play with their particular product. Neither one of these is more right or worse than the other. They are just embracing the correct way for them to work on it. So understand that and embrace it. Don't try and fight against your natural instinct for how you want to work. Focusing on the subsystems is critical. Don't try to think of everything at once. Break it down. Go through that block diagram process where you identify the different subsystems of what it is that you're trying to build, and then break those down into smaller chunks, and then break those down into smaller chunks, and get to the point where everything that you're working on is a manageable chunk, rather than trying to think, oh my God, how am I going to get to the car that is going to be my end goal, when really you could just focus on which LED am I going to use for the turn signal. And then finally, make sure you get this into the hand of the customer at some point. Like, you've got to get that feedback. You are not as knowledgeable about what your customer wants as you think you are, and I know this for a fact. I should add another bullet point on here, which is don't get into an idiotic fight with a teenager on Reddit about whether or not your product has merit. I had actually tried to promote my personal Kickstarter on Reddit, and I posted it to the electronics subreddit and just got the worst feedback possibly imaginable for an entrepreneur that is trying to get people interested in their product. It was, your product is crap, your product is overpriced, no one needs it, and then this one person, just all his entire comment was, $59, LOL. That's it. Like, nothing about the merits or anything, just like, and I can't, please tell me, help me to understand what it is that you were saying, and then got into this giant thread with this.
Do not engage the troll.
Exactly, exactly. And then for some reason I went back into that thread like maybe a year later, and down at the bottom somebody had posted in there, don't let this guy get to you, most people can't even make a cheese sandwich for lunch. So, but still, you know, get it into your customer's hands and be prepared for the feedback that you're going to get for that. As an example, I really focus on electronics prototyping because I think, for the most part, people can think of like how you would make a table and maybe how you would prototype working with wood, but electronics is kind of black magic to most people. So what we have are these things called, they're other mills, or now the official name is the Bantam Tools Desktop PCB Milling Machine, which, why did they change it from other mill? I don't know. But what you can do with this thing is you can actually fabricate circuit boards. Now, for those of you that are familiar with circuit boards, you only get 2 layers at most. You don't get solder mask. You don't get plated through holes. There are a lot of drawbacks to this as a prototyping method. But what you do get is a circuit board. And you get a circuit board in 15 minutes. You don't get it in 24 hours at $3,000 a board. You get it right here, right now, and you can do amazing work with it. You can get sub-half millimeter trace widths out of this. These are incredibly small physical packages that you can get in a very short period of time. And what you do is you basically take this, which is it's called copper clad. It's 4 inches by 5 inches. It's a phenolic resin substrate that they've bonded copper onto. And you put it into the mill right here, and then you basically just run a high precision engraving bit over the surface of it to carve out the traces and the pads where you're going to wind up soldering your parts to. This is completely incompatible with the idea of building an entire product, but for building a subsystem, for testing one sensor, for testing a new microcontroller, for testing an op-amp implementation, for testing instrumentation, this is perfect because you can do all the various different subsystems and then prove to yourself that they work. You can develop code for it. And then afterwards, when you go to do the full spins of your board, you're just doing a systems integration process of a bunch of subsystems that you know work. That's not going to absolve you from making sure that you actually hook your subsystems up together correctly, but it is a lot less troubleshooting that you're going to have to do if you know that inherently all these subsystems work before I actually took them to integration. So, how much time we got? 2 minutes. 2 minutes? Okay. So we have the residency program at the DesignLab. This is an invitation program. So you apply for a residency at the lab, and if you go through the interview process, and if we accept you, you get access to the facility Monday through Friday, 8 to 5, for a period of 4 months. You get access and the ability to use all of the equipment that we have at the lab. You get access to all of the stock materials, and then you also get a $1,000 materials budget. You get fabrication assistance from us. You can get basic project management support, basically me walking around going, are you doing what you said you'd do? Great. What we don't do is provide you with engineering resources, which may seem strange, but what we don't take from you is any kind of intellectual property. And because we don't do any engineering for you, we can't claim to own any of your intellectual property, and that is key. This doesn't cost you anything other than allowing us to do the marketing and to tell the story. It's a marketing play for Supplyframe. This is open to any individual or a team that is building a hardware project, product, art installation. Basically, there needs to be something physical. It's not just software. Again, teams of 2 to 4 people seem to work best. Number 3 is so key. Just follow up with me. If you say you're really interested in this and you're gonna send me an email, send me an email. That is the easiest way to get into this program. Just be eager to be in the program. We have a lot of very cool equipment, laser cutters, pick and place, injection molding machines, milling machines, CNC routers, 3D printers of various different sorts, types, colors, and materials. I'd be happy to go into this list in depth later, or come by the lab and get a tour. But quickly, I just want to talk about the skill set. This is the stuff that, the more of this that you possess when you walk through the door, this is going to enhance and make the time that you have there better. If you have CAD modeling skills, that's going to put you way ahead of the game. There are amazing resources on YouTube and generally online for any of this stuff right up here. So if you have CAD modeling experience, we're standardized on Fusion 360 at the lab, although, hey, use SolidWorks, ShapeUp, whatever you want to use, that's perfectly fine. But have some experience in what this thing is that's called CAD modeling. Go through a couple of YouTube videos, get some sense for how to make a virtual representation of that thing that's in your head. The more familiar you are with electronics, because we do tend to be fairly electronics heavy at the products that we design at the lab, the better you will be. That doesn't mean you need to be a double E by any stretch. But grab an Arduino and blink an LED. Don't allow yourself to be scared by that stuff. And if you can get to the point where you're actually capable of even designing the most simple of circuits, or even just grabbing an open source schematic and then designing your own PCB based on that schematic, that's going to put you light years ahead of showing up at the lab with never having actually seen a PCB or touched a PCB before. And finally, software development. I'm not going to tell you that all we do is physical hardware stuff at the lab. Everything nowadays has got software in it, so the more familiar you are with software, and chances are that's probably a larger percentage, the more effective you're going to find your time at the lab. I have a couple of things up here about different things that we built at the lab. This is the VR camera rig I got commissioned by Deutsch to build. This is the prime example right here of there is no manual, because they basically gave me this thing that said, we need to build something, we can't tell you what it is, and you can only say yes if you can promise that you can build it. You want to do it? And on top of it, it wasn't just random, it was a friend too. So if I blew this up, I was going to destroy a friendship in the process. So of course I said yes. So that's what I started with as my initial design over there in the upper left. That's what I wound up with down here. This was the first prototype that I made. It was all out of laser cut MDF. It lasted about 30 seconds. That's all it needed to do. I needed to be able to bolt 4 cameras onto it, prove that they were at a specific angle, take one still image out of all of those, and let their software engineer make sure that he could stitch all of that stuff together. And based on that working, then I was able to commit to, yes, I will build this out of aluminum, because they needed to take it somewhere out into the desert, and they shot some 360-degree time lapses for a Volkswagen promotion. So they needed it to be like super burly. This is the Willow product. If anybody has been to the DesignLab, chances are you've heard us talk ad infinitum and possibly ad nauseum about this. The little nervous Twitter from my cohorts over here, notwithstanding. So this is a fully in-house design and manufactured with the exception of the circuit board product that we did at the lab. Everything that you see there was fabricated in-house in one shape or another. It went through a full design process. We started off with our scale models and did some testing and some feel and understanding of how we wanted this thing to work and how we wanted it to look, because it was going into a hospital environment. We wanted it to be non-threatening, and we wanted to add some sort of gamification aspect to it, which is a phrase that I detest. This is an example. Everybody loved this design down here, except me. I thought it looked like a Wi-Fi router rather than something that would look friendly on the wall. And I was fortunate enough to realize that because of this infrared capability that we wanted it to have, that this corner right here would have been this just ridiculously complex geometry. So instead of saying, I don't like your design, which would have been very mean, I just said, I can't make it. So we went on to this other concept, which was called Dish. And then sort of down here, you can see the final implementation of it. That's actually mounted in a hospital room in Kansas City, where I went a couple times in the fall. Really, the whole reason this is important is because of that mold process that I was talking about. So down there, you see all of these different little circular sort of blossom-like things. There were a bunch of LEDs, or there are a bunch of LEDs in this thing, and we didn't want the light from one LED to bleed into the other. We wanted it to be this clean transition as you had the blossom grow on the face of the design. So in order to do that, you have to hide each LED from the other and just make sure that the light is guided straight to the front of the enclosure. So we needed something that we called a baffle. Now we had this incredibly complex three-dimensional geometry in there where it had to sit on top of the LED, and then we had these sort of convex convex cylinders of diffusion acrylic, and we went through 41 different ways of trying to make these things over the course of probably 2 or 3 months, trying to find the most efficient and effective way of doing it in a way that was reliable, so that once you made it, you had a 99% chance of knowing that this thing was going to be able to get glued into the enclosure without going, oh, Jesus, now we got to make another batch of these things because this method didn't work. And ultimately what we came to is, rather than trying to 3D print it, we 3D printed a series of those molds up there. And for those of you that are familiar with SLA, you can see sort of the SLA support structure on the back of this. We got this really high fidelity mold that we then used to cast a urethane rubber into there, the specific shore hardness that we needed to make sure that it would be semi-rigid but semi-flexible to be able to fit inside the enclosure. And then this is an example right here. If anybody is curious about this process, I have probably close to hundreds of these prototypes that we give away as coasters.
with the lab.
Thank you everybody for coming by. I really appreciate it. Thank you, Innovate Pasadena. Thank you very much to Katie and to Magenta and to Giovanni, who isn't here, and to Jason, my intern, and to the residents of the DesignLab. It's an absolute pleasure working with all of you and speaking with all of you today. Thank you.
Daniel. Adulation. Fantastic presentation. Really appreciate it. Very succinct. And I think a lot of people can relate to this. If anyone create anything that's a hardware or software application, raise your hand. Yeah, agile development is the way to go. Create minimum viable, have an idea of a minimum viable product. Create prototypes, test early as quickly as you possibly can. Get relevant feedback from your target audience. And then revise, reiterate, and just keep going through the process until you find something that actually works or fails fast, which is totally relevant. I'm thinking to myself, like, I should be listening to my own advice regarding my own app development. But anyway, in any case, really good stuff, and it's awesome that this resource is locally available. For those of you that do not know, Supplyframe is actually here in Pasadena on South Fair Oaks. Do you guys do tours of your facility every once in a while?
We absolutely, is it my phone?
Can you turn up just a little bit?
Yeah, exactly. Just project, Daniel. Yeah, we absolutely do give tours at the DesignLab.
Yeah.
It's by appointment, so just send me an email. Unfortunately, I didn't bring any business cards. I can go back to sort of the first slide that's got my contact information up here.
Yes, perfect.
Or Magenta, raise your hand, Magenta. Thank you. Magenta works with me at the lab. She actually did bring business cards, so contact me or contact Magenta. We'll be happy to give a tour for anybody that comes by.
Awesome, very good. Okay, we're gonna open up to Q&A now. If you have a question, raise your hand. John will walk around with the mic. No time for comments. Please save that for offline. Daniel, will you be hanging out with us for a little bit afterwards? So if you'd like to talk about a manufacturing process or debacle, please save that for offline. Thanks.
Actually, I have a question for you, Dan.
Sure.
Earlier this year, you guys had a Hackaday contest event. I'm not sure how you describe that.
The Hackaday Prize.
Hackaday prize, and you guys are giving away how much in prizes?
We're giving away $200,000 in cash money, dollar bill, y'all.
$200,000. Wow. Is it still ongoing? Because you had several different categories.
Yeah. So there are 5 categories, of which we have now gone through 4 of them, or we're on the 4th.
Right now. Oh no, I'm good.
Of which there were 4 categories. Honestly, right now, I'm blanking on what those categories were. Please, Katie, everybody. Katie.
It's the Human-Computer Interface Challenge right now, and that's going through mid-August? No, yes, something around there. So, sorry, I don't have the date. I should have looked that up. But yeah, Human-Computer Interface, so machine talk to humans talk to machines, make it a more interactive and fun and more natural experience than we have right now. So, all open source. 20 projects that enter into that get $1,000 for seed funding, and then they're automatically pushed to the grand prize final round, and you can win up to $50,000 for if you win the first prize. Hackaday.io/prize.
Cool. We were clearly over-prepared for this moment.
Yeah.
And so is this contest going to, a project going to start again next year with another $200,000?
Yeah. Definitely, yeah. This is our 5th year, so we're gonna. This is our 5th year doing this, and we love doing it. It's great for the community. It gets people really excited. We're looking for open source hardware projects, getting people involved in making the world a better place, changing things for the better. So yeah, this is definitely something that we want to continue, and I'm sure we will do it for our 6th year, 7th year, 8th year, all of that. It's going to be an ongoing thing.
What were the other 4 categories?
Oh gosh. The first one was the Open Hardware Challenge. The second one was, guys, I should know this better. Thank you.
Sorry.
I know. Robotics. It was a robotics module challenge, and then the third one was the power harvesting challenge. We're in the human-computer interface challenge right now, and then the next one's going to be the musical instrument challenge, which I'm super excited about. I am not musical at all, like musically inclined, but I'm really excited to see what people come up with. So it should be a good time. Yeah.
Thanks. Thank you.
You guys out there know who Giorgio Moroder is? Anybody?
Yeah.
So there's a chance that I'm going to be able to interview Giorgio Moroder as an intro to this music instrument thing, and I am so nervous about that. You got no idea. Anyway, so questions?
Hey Dan, thanks for speaking today.
Sure.
I have a question about like some of the prerequisites that you had listed, like the 3D modeling, CAD, programming, electronics. There are, for some of the people who don't have a lot of those kinds of like knowledge, is there some kind of training program, or like do they have to get through the prerequisites in order for them to be resident? Because the problem is in a lot of startups, it's like a lot of people who are getting into startups have a really good knowledge specialist, but they're not generalists in a lot of these different programs and materials.
You've just identified the single greatest challenge for the lab. Simple right there is that people have ideas, but they don't have, through no fault of their own, the skill set that they need in order to bring that to reality. There are usually two types of people that come by the lab to talk about the development of a project. The first type are the ones that are coming by absolutely, hands down, looking for free engineering resources. And they come in, they shake my hand, they get really needy, and then I try to get them out as fast as possible. The other ones that come in are people with these very, very interesting ideas, and they just don't, they would love to be able to work on it themselves. They're super passionate about this, but they just don't know how to model something in CAD. It's just not something that they realized was going to be an important part of it. So without making any concrete promises right now, I will say that I have absolutely identified that lack of training in that area as a need, as a crucial need, and I'm hoping to be able to put curriculum about that together, and not small either. I'm thinking like probably 2 nights a week for a couple months, so that you go through the entire process of designing in CAD, designing electronics, troubleshooting, fabricating, using all the equipment in the lab, doing a small piece on design for manufacturing, actually getting a couple of things manufactured. Ideally as a roadmap to getting you into the lab to actually continue development, but honestly for just the betterment of the community, right? So.
Last question over here.
Sure.
I know that your company is rather large. Can you talk about your other divisions, and do you have this in San Francisco, another lab like this, or is this unique to Pasadena?
Sure. This is unique to Pasadena. This is not an inexpensive facility to own, manage, and run. I say that because I see my own expense reports every month. Thank you, American Express. So no, it is the only facility that Supplyframe runs like this, that's owned by Supplyframe. Obviously, there are any number of maker spaces that are now sprinkled across the United States, California, Los Angeles, the world. At this point, Supplyframe as a company is in fact fairly large. We have offices here in Pasadena. That's where the main corporate office is. We have an office in San Francisco. It's significantly smaller. We have offices in China, in Austin, Texas, and in Belgrade, Serbia, and I'm probably sure I'm forgetting. That's pretty much it. How many employees? Like 250 around the world. The majority of that is on the ad operations side. So for the component search engines that we run, we sell ad space on there, and that's one source of revenue. And then we have these bill of materials management tools that we sell seat licenses to. We have APIs that we sell access to. There's a whole bunch of different software stuff where a lot of the revenue gets generated. I don't have a profit and loss statement for the lab, thank God. So I don't have to really worry about that too much yet. And if there are any board members in attendance right now, thank you very much. But no, yeah, so it's primarily a software company, for sure.
Awesome. Thank you so much for the questions. Awesome answers.